Forward kinematics is the process of going from like a shoulder or a hip out to the hand or the foot, or in like robotics it's called the end effector. So that's forward kinematics. That's saying move your shoulder by a certain angle and then your elbow by a certain angle, and then sometimes maybe like your wrist by a certain angle. Inverse kinematics is the opposite. It's going backwards. So it's saying if we want our hand to be at this point in space, what angles do the shoulder and the elbow need to be at in order for that to happen? If you make the assumption that the length of your upper arm and your forearm are the same, you can get pretty far with just this. So looking at this, all we're gonna have to do is define the distance from where we want the hand to the shoulder. D divided by 2 would be L cosine theta. So divide by L and then take the inverse cosine of that, and that'll give you theta. This is the shoulder angle, and then the elbow angle is pi minus this. So pi minus 2 theta. So then this angle would just be 2 theta. Okay, so real quick, because I feel like I didn't really explain it well before. The trick with this is that once you assume that the upper arm and the forearm are the same length, then you get this isosceles triangle, and because of the geometry of the fact that this angle up here is equal to pi minus 2 pi, and then this angle is equal to pi, like 180 degrees, minus this angle, which is pi minus 2 pi. The pi's cancel and you just get 2 pi. So once you find the angle of the shoulder, the angle of the elbow is just twice that. And that's the simplification for like an IK arm or a leg when you make this assumption. So let's try to make this happen. We're gonna say let arm equal, we're gonna say shoulder, and shoulder is gonna be an object with an X. Start at, I want to start at low on the screen actually, and then Y, so like a Y of like 300, and then an angle, a theta, will start at 0. So we'll have the shoulder, the upper arm, which just has a length for now, the elbow, which just has a rotation, and then forearm, which will have a length. Oh, that is going to be it for now. Actually, let's add it target X, say 200, and Y 100. Okay, and this is going to be the target for where we want the hand to be. So then down here, actually I'll make a draw function. So we'll say draw will be a function. We're going to draw, I want to draw a circle at the shoulder, the elbow, and the hand. So we'll say translate this dot shoulder dot X, this dot shoulder dot Y, and then circle, and let's make sure we put all this in a push pop just so we don't get any weird side effects from calling our arm.draw function later on. This dot shoulder dot X, this dot shoulder dot Y, and then we're going to draw a circle at 0, 0, since we've translated our whole world coordinate system to the shoulder, and we'll give it a radius of 15. And then we will translate, or no, then we're going to rotate this dot shoulder dot theta, and then we're going to draw a line from this dot shoulder dot X, this dot shoulder dot Y, and then since we've rotated our whole coordinate system, we can just translate, we can draw a line along the X axis. by length. This dot upper arm dot length, and nothing in the y direction. So let's see what this looks like. Let's say arm dot draw. So we translated and we drew a circle. And we rotated, and then, oh, yeah, so we'll go from 0, 0, right? Because our whole coordinate system is at the shoulder already, so we don't need to translate again. There we go. All right, and now if I were to say arm dot shoulder dot theta equals mouse x divided by 100, you can see we get some rotation. Perfect. So next we're going to, now we drew the line. Now let's move out from the shoulder to the elbow. So we're going to translate again. We're going to translate along the x-axis by this dot upper arm dot L. And then we're going to draw a circle again. 0, 0, 15. Oh, and 0 in the y direction for that translation. Nice. I'll put this back on. Arm dot shoulder dot theta equals mouse x divided by 100. Now we're at the elbow. We need to rotate by the elbow theta. And then we're going to draw a line. This dot forearm dot L. We've got this going on, so I can show you arm dot elbow dot theta equals mouse y divided by 100. So now we can move the elbow by moving the mouse in the y direction and the shoulder. And then the next thing we're going to do is we're going to translate from the elbow out to the hand. So translate, and again we've rotated already, so our x-axis is pointing towards the hand, so we just need to move in the x direction by this dot forearm dot L and 0 for the y, and then we can draw our hand. Cool. Maybe we could even do like a rectangle. And we'll make sure we have rect mode as center. We'll draw a rectangle 15. Oh, and x direction, so like 25, 10 maybe. Cool. Make that 200 so it's more in the center. All right, so what we've done now, this is forward kinematics, right? So I'm controlling the rotations and getting movement in that way. Next, what we want to do is inverse kinematics. So we want to go from a target point and have the angles be figured out automatically. So we're going to say arm dot target equals, we want x to be mouse x and y to be mouse y. All right, and it's currently not doing anything. So let's do a function called ik. So ik will be a function. And the first thing I want to do is just draw a line from this dot shoulder dot x, so from the shoulder to the target. And I have to call arm.ik for that to work. Nice. Okay, so this is going to be our distance. And then from there, we're going to just calculate these angles accordingly. We'll say let d equal the distance from the shoulder to the target. And then we can say this dot shoulder dot theta equals d divided by 2 times this dot upper arm dot length d divided by 2 divided by L equals cosine of theta. So we need to just take inverse cosine of all this. All right, something's happening. So that's good, but it's not pointing towards our target. Oh, but that makes sense. Yeah. Okay. It shouldn't be pointing towards the target because it's pointing towards the elbow. So we got to find the elbow now. And to do that, we'll do this dot elbow dot theta equals this dot shoulder dot theta. Oh, I didn't multiply by 2. And it is working. As you can see, for this one dimension, it totally works, which is great. Now we just need it to rotate an additional amount based on where the target is relative to the shoulder. So I forgot that. So we need another thing here. So we need a let d theta equal d theta equal a tan 2 of this dot target dot y minus this dot shoulder dot y, comma, this dot target dot x minus this dot shoulder dot x. Okay, that's d theta. Let's try adding. Oh, I think we could just do this. We'll try adding it to this. Plus d theta. I'm not sure this is going to work. Oh, yeah, no, totally not. That's fine. What we're going to do is we're going to say this dot target dot theta equals that. And we'll add a theta argument to this, or property to this, and just initialize it as 0. And then up top here, after we translate to the shoulder, we're going to rotate by the shoulder plus this dot target dot theta. So we had to call IK before draw, I think. And then yes! Check it out. Inverse kinematics.